YouTube channel, Mathematics Made Easy. So in today's video, we are going to look into integral calculus. Okay, we've started this topic, and we are going to do more on integral calculus. All right. So from my previous videos, I explained some very important key points in integral calculus, and then how to integrate some functions in integral calculus. All right. So in today's video, we are going to look more on this topic. Okay. So if you are new to this channel, please don't forget to subscribe, like, comment, and also share. Okay, guys. So let's dive into the work. So here's another property in the topic, which is integral calculus. All right. So let's say we have this kind of function. Let's say f of a plus xb. All right. Then we want to integrate this. Okay. So we want to integrate f of a plus xb. So with respect to x. All right. So then here we are going to make use of substitution. Alright, so then we say let u be equal to this term inside the bracket, which is a plus xb. The next thing you are going to do is to differentiate with respect to x. Alright, then if you do that, so we have the u over the x is equal to u. If you differentiate a, this is a constant, you have 0. Then if you differentiate xb, we have b. Then the next thing you're gonna do is to make the x the subject of the formula. And then if you make the x the subject of the formula, so we have the x is equal to 1 over b, the u. Alright. So then we come back to this integral. So we're gonna have integral f. So instead of writing a plus xb, then you write u. So we have f of u. Then instead of you writing the x, you write 1 over b, the u. So 1 over b is a constant. So you can bring that. So we bring 1 over b out, so we're going to have 1 over b, then integral of f of u, the u, right? So integral of small f of u, the u, so we can just call it capital F of u. So then we have 1 over b, then capital F of u, then plus c. Don't forget, we have a constant. And then you remember that u is a plus xb, so then you can substitute back u to be a plus xb. So we have 1 over b, then f of a plus xb, then plus c. Alright? So that's that. Then we are going to do some examples using this particular property. Okay? Now, example 1. So I will do 2 examples or 3 examples on this property. Okay? So example 1, let's say we have integral of square root of 2x plus 3 dx. Alright? So how do we integrate this? You make use of the same method that we did here. So you're gonna say let u be equal to this term inside the square root, which is 2x plus 3. Alright? Then you differentiate with respect to x. We have the u over the x is equal to 2. Then if you make the x the subject of the formula, so we have the x is equal to 1 over 2, the u, alright? So then if you come back here, then you have integral of root. So instead of you writing 2x plus 3, you write u, then instead of you writing the x, write 1 over 2, the u. Alright, and don't forget 1 over 2 is a constant, so you can bring it out. So we bring that out, you have 1 over 2, then integral root u, the u. Then how do you integrate square root of u? So this will be 1 over 2 integral of u raised to the power of 1 over 2 the u. Don't forget, square root of u can be written as u raised to the power of half. And then from the formula of integrating, from our previous video, I said if you have integral of x raised to the power of n dx, I said this is going to give you x raised to the power of n plus 1 and over n plus 1 plus c, right? So then you apply the formula here. So if you apply the formula here, you're going to have 1 over 2, then u raised to the power of 1 over 2 plus 1, then over 1 over 2 plus 1, then plus your constant c. Alright? So then 1 over 2 plus 1, that should give us 3 over 2. Alright, so let me just clean this. Clean this. So we have 3 over 2, then we're going to have 1 over 2, then into bracket u raised to the power of 3 over 2, then divided by 3 over 2, then plus c. Okay? So this will give us 1 over 2, then u raised to the power of 3 over 2 multiplied by 2 over 3 plus c. So we have 2 we cancel out 2 here. So what we have now is 1 over 3, then u raised to the power of 3 over 2, then plus c. Now don't forget that u is 2x plus 3. Then substitute back to be 2x plus 3. So we do that, we're going to have 1 over 3, then into bracket 2x plus 3 raised to the power of 3 over 2, then plus c. Alright, so that will be the answer to that particular integral. I hope we are getting it. Alright, so let's try and do another example using this property. Right, so let me give you one example from trigonometry. Alright, trigonometry. Yeah. Alright, so example 2. So let's say we have integral of sine 2x plus 3 dx, right? So we have integral of sine 2x plus 3 dx, alright? So then if you make the substitution, we're going to have u equal to x plus 3, then if we differentiate with respect to u, and then with respect to x with that. So if we do that, we're going to have the u over the x equal to, then you make the x the subject of the formula, then we have the x equal 1 over 2, the u, right? Then if you write your integral, then we're going to have 1 over 2 integral sine. Instead of you writing this, you are u, then the u. So don't forget, if you integrate sine u, with respect to u, you have minus cos u. Take note of that. So we have negative cos u, then plus constant c. So we have negative half cos u, then plus c. Alright, so don't forget that u is 2x plus 3. Alright, so the answer will be negative half cos 2x plus 3, then plus your constant c. Very simple and straightforward. You can see it is very easy, alright? It's very easy. So let's try and do more examples. Okay, so example 3. So we have, let's say we have integral of, let's think of our example. Let's say we have integral of, let's say, tan. Should we use tan? Yeah, let's use tan. Let's say tan 2x plus 4. Alright. I like 2 as well. I like 2 as well. Alright, the x. So how do we integrate this function? You have to be very careful when integrating, okay? Very careful, especially indefinite integral. So you make your substitution as always. Yeah. U equals 2x plus 4. Then if you differentiate with respect to x and make the x the subject of the formula, we have the x equal 1 over 2, then u. Then we're going to have 1 over 2, then integral 10u, then u. Now, how do you integrate 10u? Now, this is how you integrate 10u. You can rewrite 10 u as sine u over cos u. Take note of that. Alright? 10u is sine u over cos u. So if I write 10u, then I'm going to have 1 over 2 integral of sine u over cos u, then du. Okay? Now, what do you notice here? The derivative of cos u is negative sine u, alright? But here, if you look at the numerator, we have sine u, alright? So, what do you think we can do? Right? So, I can say this is equal to 1 over 2 then multiply by negative derivative of cos u. Let me just write d du of cos u, okay, then over cos u, then du. Take note of that. If you differentiate cos u, we have negative sine u. Negative sine u. The negative sine u multiplied by negative 1, we have back our sine u. So this is not changing anything, right? It's just a matter of manipulation, right? If we differentiate cos u, we have negative sine u. Then negative sine u multiplied by negative 1 here, we have back your sine u. Are we getting it now? Alright, so let's move on. We like to tell you guys a very special property. Okay? And here's the property. I hope I will do the property next class too. Yeah, next class I'm going to teach you guys the property very well. And here's the property. Before that, we can bring out this negative sign out. So we do that, we have negative half integral of d du of cos u, alright? Then over cos u, the u. Okay? So now here's the property I want to introduce to you guys. If you have integral of f prime of x, f prime of x over f of x dx. So this is going to give us natural log of f of x plus c. This property. Alright? So if we have integral of f prime, this, don't forget, f prime is derivative of f of x. Okay? So we have integral of f prime of x over f of x dx, that is the derivative of f of x then over f of x. So this is going to give us the natural log of f of x then plus c. Now, look at this. Derivative of cos u is the numerator, then we have cos u at the denominator. So definitely this is going to give us natural log of cos u. You can say very simple. Alright? So this will give us minus 1 over 2 natural log of cos u. Alright, so you can also, this negative sign right here, you can also have 1 over 2 multiplied by natural log of cos u plus c, don't forget the plus c. So then this will give us 1 over 2 natural log of 1 over cos u, okay, plus c. And then once it's 1 over cos u, 1 over cos u will give us sec u. So we have 1 over sec u plus c. So that will be the what? That will be the answer to this beautiful problem. Alright? Sorry, ln sec u. Oh my bad. Ln sec u. So that will be the answer to that beautiful problem. So that will be the end of our today's lecture. So if you like this kind of video, please don't forget to give me a like, comment, share, and also subscribe. Thanks for watching. See you next time.